that rock here with some math. Here we're going to talk about parameterized functions. So the example I have here, we're using t as our parameter. That it doesn't have to use that variable, but frequently the parameter is time, and so traditionally t is used as a parameter, but not always. And here we have x is defined as 2 greater than whatever t is, and y is defined as 1 greater than the square of whatever t is. And one way to handle these parameterized functions to find out what function we're dealing with is just to create a table of values. So you choose a t value, and then you graph your x and y that come out. And so if I choose, -1, since x is always 2 bigger than whatever the t is, x is 1. So if I choose 1, 2, 3, and 4, and so forth, I'll get a table of x values that are always 2 bigger, so 2, 3, 4, 5, 6, and so forth. And then remember, the y is 1 greater than the square of t, so if I square a negative, it becomes a positive. So a -1 squared is a +1, and I add 1 to that, I get 2. 0 squared is just 0, so we just have 1. 1 squared is 1, plus 1 is 2. 2 squared is 4, but it's 1 greater than the square, so it's 5. 3 squared is 9, but it's 1 greater, it's 10. And so I can see this is getting big. 4 squared is 16, and 1 greater than 16 is 17. And then you can plot these points, and maybe you'll be able to tell what kind of graph you're dealing with, what kind of function you're dealing with. So I don't see any negative y values, so I'll put my x-axis down low. Can we see that? Yeah, we can. Okay. And I'll just plot the points. Yeah? So when x is 1, y is 2. So when x is 1, y is 2. There's the point, okay? When x is 2, y is 1. So when x is 2, y is only 1. And when x is 3, y is 2 again. So when x is 3, y is 2. Now notice we started at t, which sometimes represents time, -1. So we chose to start there. We could have chosen somewhere else. So we started at -1, and then we went to here. Then we at time 0, and then from time 0 to 1, say time is going by in seconds maybe, then this is at some key point, maybe when the object is closest to the radar that's gathering the information or something. That's time 0. But as it approached that station, radar station, maybe that's time before it gets closest, and this is time after or something, I don't know. Or the parameter could be something completely different than time. So anyway, we're going to keep going here. What was the last thing I left off? 3, I got 5, 4, I get, I had 3, I get 2, at 4, I get 5. So at 4, I have 5. So this is 3, 4, 5. And then it just is taking off from there, because at 5, it's going to be at 10. So I have 5 here. 10 is going to be way up here, 6, 7, 8, 9, 10. So we see it looks very parabolic, so I don't know that was curvy. I should check it and see, but it's looking like a parabola. Okay, or at least part of a parabola if this is where I start. But remember, we chose the starting time, unless in the context of the problem you're given a starting time. Now, another way to handle this, or to verify that it is a parabola, is to do something called eliminating parameter. So remember, x is equal to 2 plus t, and y is equal to 1 bigger than the square of t. So 1 bigger than the square of t. But I can solve for t up here. I can subtract the 2 over and have x minus 2 is equal to t. Can we see that on the screen? Yes, we can, but barely. I need to zoom in. So what I did was, I said, well, if x is 2 plus t, then I can subtract this 2 from both sides, and t will be equal to x minus 2. And now I'll take that t and plug it in for t in the y equation. So I know that t, here let's highlight it, t is the same thing as x minus 2. So I'm going to plug that in for t, square it and add 1. So I get y is equal to x minus 2 squared plus 1. Well, of course this is quadratic. This is a quadratic, and it shifted to the right 2 and up 1. Oh, yeah. Look, normally the ghost parabola, the parent parabola maybe you call it, looks like this, right? And we've just taken the parent parabola and shifted it to the right 2 and up 1 in order to get this parabola. So yes, it is a parabola, a quadratic function. That's an example of a parameterized function. Math made simple, Simpson Math.